All right. So, as I was saying, that the shells can hold specific number of electrons in them. All right.
Yes.
So, for this first shell, I can put this formula. I can use this formula, and for here for the first shell, I have to put the value of n equivalent to 1. The value of first shell will become 1. So the number of electrons which can be accommodated in this case will become 2 multiplied by square of 1. The value will become how much?
2.
2. So there can be 2 electrons in the first shell. Now apply for the second shell. For second shell you will have 2 multiplied by power of 2. The answer is
8.
8. So these are the electrons which can be calculated using this formula. So these shells can hold up to these number of electrons. The first shell will hold maximum of 2 electrons. These are the maximum quantity of electrons. Maximum quantity. The maximum amount of electrons which can be held or accommodated in these shells. So first will contain 2, second will contain 8, third 18, and fourth 32. So that's the capacity of the shells which you have to learn. Now the next thing is about the atomic orbitals. Basically they are missing one thing which I need to add here. It is about the subshells. They have not mentioned anything about the subshells, or you can call them as sub energy levels. Now what are these subshells or sub energy levels? These are the smaller regions within the shells which contain the electrons. Basically the shells are still further categorized into smaller regions where the electrons are held. These are called subshells or sub-energy levels. Is that clear?
Yes.
Now we have 4 different subshells here. I think they have mentioned over here exactly. The subshells are mentioned here. The subshells are of 4 types here. The subshells are, do you know the names of the subshells?
Yes.
What are the names?
S, P, D, F.
F. Very good. These are the 4 subshells within any shell, but it cannot be within same shells, but in different shells. So these are the 4 subshells which are present in the shells. Now these are the names as well as the symbols of these subshells. These are both the names as well as the symbols of these subshells. Now these subshells have their different capacity to hold the electrons and they have their different specific shapes. S, P, D and F subshell will have their own particular shapes. Now we can check these shapes over here. This is the shape of the S subshell. This is the shape of the S subshell. The shape is spherical. It is completely spherical shape. But for our convenience, when we draw this structure in 2 dimensions, we just draw a circle. This is a simple picture of the sphere. Is that clear?
Yes. Yes.
I need to add my own notes here because some portions are being missed here. So let me add my notes here. Basically, the subshells have a different number of the orbitals in them. I am going to show you the subshell first, and in your book you cannot see the different types of the orbitals present in the p subshell. Basically, in this book you can see that they have shown this picture, this whole picture, but it is not split it into its own particular orbitals. As you told me that there are 4 subshells, right? The S, P, T and F, right?
Yes.
You have seen the diagram of the S subshell, but what about the P subshell? The P subshell has this kind of the shape. All of these 3 are the orbitals of the p subshell, but all of these have one similarity between them, which is they have two clouds of the electrons. These are the clouds of the electrons, which we know as lobes, L-O-B-E, lobes. These are the lobes of the electronic cloud. So this shape has 2 lobes here, left and right. This shape has 2 lobes here, and this shape has again 2 lobes. But what are these? These are basically the orbitals of the p subshell. We call them orbitals. So p subshell has 3 orbitals: px, py and pz orbital. Is that clear?
Yes.
And their orientations are basically according to the x, y and z axis. You can see that there are 3 axes drawn here: x, y and z. So if the name of the orbital is px, if the name of the p subshell is px, then it will be oriented on the x-axis. So you can see that both of the lobes of the p orbital are drawn on the x-axis. Is that clear?
Yes.
The x-axis is according to your own will. You can either take this as the x-axis, or you can even take this horizontal line as the x-axis. It is upon your own will. Either you draw horizontally or vertically or diagonally. So it depends upon you. But once you have constructed the axis, you will have to specify the orientations of the 3 orbitals px, py and pz. So this is the px orbital, and then about the py. The py is that orbital which will be oriented on the y-axis. Alright.
Yes.
And the pz is that orbital which is oriented, or in which its both the lobes lie exactly on the z-axis. So the orientation of the axis is upon your will, but once constructed you have to show their direction. Now these 3 are the orbitals of the p subshell, because p subshell contains 3 orbitals px, py and pz. Now if you combine all of these 3 orbitals into a single diagram, you will get a picture like this. This is a picture when all the 3 orbitals of the p subshell are combined together, and this is a picture which is mentioned here. The 3 orbitals of the p subshell are collectively shown here. Is that clear?
Yes.
Alright. Now since they have not shown the shapes of the d subshell and the f subshell, which means I can exclude those shapes as well, but I just want to show the overall picture of the d subshell. These blue colored are the 5 orbitals of the d subshell, and they have, you can see, they have different shapes. Although these looks similar, but they have some small minor differences. So these 5 are the orbitals of the d subshell, and they are in total 5 orbitals of d subshell. And this one, this is the 1 orbital of the f subshell. In total there are 7 orbitals in f subshell, and over here one of that picture is shown. Only 1 orbital out of 7 orbitals are shown here. So this is just for your knowledge. Is that clear?
Yes.
Alright, then moving ahead, we have just seen that the s subshell is spherical type, and p subshell has 3 orbitals in them, which you have seen the diagrams. Now here they are telling that they are 3 orbitals. So what about how many orbitals are they in s subshell? I didn't tell you that. How many orbitals are present in subshell s? Do you know how? There is just one, that is s itself. S is a subshell and s is the orbital. S is a subshell and s is a orbital. So basically there is just one orbital in the s subshell, which is s itself. Is that clear?
Yes.
And for any type of the orbital, either it can be s, it can be px, it can be py, or it can be pz. All of these orbitals will contain, each will contain maximum of 2 electrons. All of them. Maximum 2 electrons. This is the maximum value. And minimum 1 electron. They can maximum contain 2 electrons and minimum 1 electron. But if there is 0 electron, which means no electron, then that kind of atomic orbital will not be shown. It will not be shown because it is an empty. It will be an empty orbital, so it will not be shown. So you will either show 1 electron in the orbital or 2 electrons in the orbital. Is that clear?
Yes.
Now here, how many orbitals are present in the d subshell? There are 5. There are 5 orbitals of the d subshell. And how many orbitals are present in the f subshell? These are 7, which I told you before. You can see them in my notes as well. Here, the s subshell has 1 s orbital. The p subshell has 3 orbitals, which are called px, py, pz. The d subshell has 5 orbitals. Their names are not need to be learned. And f subshell has 7 orbitals, and I have shown you their diagrams. And for all of these orbitals, whether s orbital, p or d, they will contain a maximum of 2 electrons each. They will be maximum 2 electrons each. I think I should show you the names because if we go towards the electronic configuration, there must be the names of the d subshell as well, but they have not shown some anywhere here. Okay, there are some differences between your board and the Cambridge, so that's what I'm looking together. Like I'm basically comparing the literature in the OCR versus Cambridge. So some things are not shown and some other things are shown here. Like for example, this formula which we used here, 2n square, to calculate the value of the electrons in any shell. This formula is not used in the Cambridge. Like the students are not made familiar with this formula. Anyways, the other things are the same. So in if there are 5 orbitals in the d subshell, then can you tell me that how many electrons will be present in the d subshell in total?
10.
Very good. 10. Since there are 5 orbitals and each orbital contains 2 electrons, so there will be 10 electrons in the d subshell, and for f subshell there are 7 orbitals and each orbital contains 2 electrons, so the total number of electrons will be how many?
14.
14. Good. So 14 electrons are present in the f subshell. We do not need to see their, we do not need to learn their shapes. All right. Now, how do we represent the orbitals? So you can see that orbitals are basically the shapes of the subshells. These are the smallest regions of the shells where the maximum probability of electrons can be found. Orbitals are basically those regions where maximum probability of electrons exist. So we have seen the number of the orbitals in these respective subshells. Now we can represent them in the form of the boxes. We call it as electrons in box. Electrons in box. So there are, for example, in case of S subshell, there is just one box, which represents that it has the S subshell has only one orbital. The name of that orbital is S. S is the subshell. The names are written on the left. So the name of the subshells are written on the left, and the boxes represent the number of the orbitals. Is that clear?
Yes.
And for p subshell, there were 3 orbitals. What were the names?
The names of what?
The names of the orbitals of p subshell.
PX, PY, PZ.
Good. Since you are not made familiar with the names of the d orbitals, so I will not write their names, but there are 5 orbitals here, and for f there are 7 orbitals. Now they have calculated the total electrons as well. So this system of showing electrons is called electron in box. Electron in the boxes. Now, when the electrons are shown in the boxes, they are shown using the arrow signs. The arrows you can see here, they are of opposite directions. One arrow is upward and the other is downward. What do you know about the signs of these arrows, like upward and downward? What they do represent?
The different directions of the electrons.
And what are those directions?
Opposite.
Like direction in terms of what? Direction in terms of what?
Up and down.
Do the electrons move up and down?
They're opposite to each other when they spin.
When they spin, yes, the direction is spin. All right, or in other words, the direction of spin can be either, do you know the direction of the spins?
No.
Whenever you spin, for example, in which direction you can move if we are spinning?
Left and right.
Spinning is not left or right. Spinning can be either clockwise or it can be anti-clockwise.
Yes.
This is clockwise direction, it is anti-clockwise direction, and that's what they are basically expressing here. You know where the electrons spin? Where do the electrons spin in the atomic structure?
The subshells.
Okay, the electrons spin within the shell and then in the subshell and then in the atomic orbitals. But spinning means to move on its own axis. The electrons are moving on their own axis. That is the representation of the spinning. Like if it is the electron, if I'm making a large size, this one sphere is representing one electron. This electron will be spinning on its own axis. It can be either clockwise direction or it can be anti-clockwise direction. Are you getting the point?
Yes.
So these are basically the spin direction of the spins. So we represent these directions of clockwise and anti-clockwise using these arrows. The upward arrow is represented for the clockwise direction and downward arrow is represented for the anti-clockwise direction. Since any orbital can contain maximum of 2 electrons, so the electrons cannot spin with the same direction. They cannot spin with the same direction. They have to be spin with opposite direction. Only then the repulsion between the electrons, since you know both electrons carry the negative charge, this contains negative charge, the other electron also carries a negative charge, so they will definitely a factor of repulsion between them. But the repulsion can be minimized. It can be minimized if we consider that their spinning directions are opposite. But if their spinning direction were otherwise considered to be same, then they will have very high repulsions between them. Are you getting the point?
Yes.
So that's why the electrons are shown with the opposite signs when placed in the same orbital. Okay, so here there is some representation of the shells, electrons, subshells and the orbitals. Now let's start from the first shell. The first shell is n is equal to 1. In the first shell there is just one subshell S. I need to show you this picture as well from my notes. Shells, subshells and the orbitals. Okay, here's the table. In this table I have drawn the columns. This is showing the shell number. If it is the first shell, then in the first shell there is only one subshell, which is S. Alright?
Yes.
And when it is the second shell, 2, then in this second shell there will be two subshells, the S subshell and the P subshell. So there are two subshells in the second shell, and in the third shell there are three subshells, S, P, D, and from 4 shell up to 7, I have not written those shells. The shell number 4 up to 7th shell, there will all of the 4 subshells, S, P, D and F. Are you getting the point?
Yes.
Alright. So from shell number 4 to 7 there will be all the 4 subshells, but from 1 to 3, from shell number 1, 2 and 3, there will be subshells of 1, 2 and 3. Now we will also represent the subshells with the number of the quantum shell, like the principal quantum number. The principal quantum number is used along with the subshell. This 1 over here represents that it is present in the first shell. Is that clear?
Yes.
And the 2 represents the second shell. So second shell, this S is present in second shell, this P is present in the second shell. We can also expand these in terms of the orbitals. For s subshell there is just one orbital, which is s itself, both for first shell and second shell. But the p subshell in case of second shell will be expanded into its orbitals, which are px, py and pz. So that's the arrangement of the shells, subshells and their orbitals. Now here we can see the boxes to represent the orbitals. If there is just one box, it means there is just one orbital. So for 1s, which means the shell number is 1, and it has only s subshell, it will be represented by one box which will contain 2 electrons. If we move towards the second shell, then second shell has both the s subshell and the p subshell, since there can be only 2 subshells in the second shell. S has only one orbital and p has 3 orbitals, and all of them contain 2 electrons each. So in total there will be 8 electrons. And for the third shell, there are 3 subshells, and all of them have these number of the electrons. Is that clear?
Yes.
Okay, now we have to place them according to the energy levels. The energy levels, or basically the energies of all these shell and the subshells combined, are placed according to the energy levels. As I told you before, that if I consider any hypothetical atom which has the nucleus at the center and then there are shells around them, we call these shells as the energy levels. Is that right?
Yes.
Why did we call them energy levels?
Because the electrons, each electron has different energy.
Yes, exactly. Since we refer to the different energies, then in the same way the shells and subshells have their own different energy values. I think I don't know if they have mentioned the energy order of the subshells or not. Do you know the energy order of the subshells?
No.
S has the least energy, P has more than S energy, D has more than P and S, and F has the highest energy. That's the trend according to the subshells. Alright?
Alright.
Okay. So the shells have their different energy order, and the subshells have their different energy orders. So we can now categorize them into the different energy levels by combining them. So what we see that the 1s has the least energy and 2s has more than 1s, 2p has more than 2s. So if I combine them in a linear fashion, if you are confused with this order, I will write this in the linear fashion. 1s, do you know the linear fashion of these subshell and orbitals combined according to the energy order?
No.
Okay, 1s has less energy than 2s, which has less energy than 2p, less than 3s, less than 3p, less than 4s, less than 3d, and then 4p. There's the energy order of the shells and the subshells combined. Is it clear?
Yes.
Any question from here?
No.
They have basically arranged all of these shells and subshells in this vertical way. vertical along with vertical as well as diagonal way. This y-axis represents the energy, and then they have placed all of these shells and subshells in the energy level. So you can see here that 1s has least energy, then 2s, then 2p, then 3s, 3p. But after 3p, if you look closely, after 3p comes which orbital, or which subshell and orbital?
4s.
4s. After 3p comes 4s, and after 4s, which one?
3d.
3d. And after 3d,
4p.
4p. So that's the same here. After 3p comes 4s, and from 4s comes 3d, and after 3d comes 4p. So you have to learn this order accordingly. So that's how we arrange them. Now the order of the arrangement according to the energies also means that we have to fill these shells and the subshells accordingly when the electrons are put into them. Like electrons have to be placed according to these energy order. But for electrons, you must know the atomic number of that element. If the atomic number is given, it will mean that you will also know the number of the electrons present in that particular atom. So here starts the filling shells and the subshells. So here there must be some rules which need to be followed. For example, the electrons are added one at a time. Electrons are added one at a time, and then the lowest available energy level is filled first, which means the one which is lower in energy, and that each orbital has to be filled singly, and after singly filling all the orbitals, they will now be pairing. There will be pairing of the electrons. First there will be just singly filled electrons, and then there will be pairing of the electrons. The 4s orbital is at a slightly lower energy level than 3d, which we have just seen before. So I'm going to show you the table of the filling of the electrons, or I think orbitals occupied electron configuration. I can show you this whole table of filling the electrons according to the energy levels from my notes, so you can have a clear picture. Okay, from these notes, this is a whole table which represents the electronic fill up of the elements. Now start from the hydrogen first. What is the atomic number of the hydrogen?
1.
1, which means it will have only one electron, and since the electronic configuration starts from 1s, so 1s has one electron in it. So it is shown like this, and if we represent them in the case of the electron in the box, then it means that one box will be represented along with one electron in that box. Now about the helium. Helium has atomic number 2, which means has 2 electrons. So 1s2. Now its electrons are filled accordingly. So the second electron is paired in the opposite direction within the same orbital or within the same box with the opposite spin. Clear?
Yes.
Then comes the lithium. The lithium has atomic number 3, which means it will have 3 proton and 3 electron. So the filling of 3 electrons is according to this. 1 after 1s comes the 2s, and there can be 2 electrons in the 1s, and after that will come the 2s. Basically the electrons are filled according to this order. First you will write 1s, okay,
Yes.
you will put an arrow here, so 1 electron has been filled in 1s. Then you will write another electron which is again on the same orbital, so this orbital is now filled. Now you will move to the second one, because you still have 1 electron left. As there are 3 electrons, so you have utilized 2 electrons, but you are left with 1 electron. You will put that third electron in the 2s with the upward direction. It is a better way to always start with the upward direction. So now you have adjusted all the 3 electrons in these 2 orbitals or 2 subshells. Is that clear?
Yes.
Now comes the beryllium. Beryllium has another extra electron compared to lithium, so that fourth electron will be accommodated in the same 2s with its opposite spin. After that comes boron. The boron has 5 electrons. So after filling both the 1s and 2s orbitals, you will now move to the 2p subshell, because the energy order was according to this. 1s had less energy than 2s, which had less energy than 2p. So the fifth electron will now be accommodated in the 2p with 1 electron. Here you will see a trend here. I am going to show you all these all these elements at the same time. From boron to neon, you have 2p subshell. Now this p subshell has 3 orbitals, and I will label these 3 boxes in the form of their orbitals. It is px, this one is py, and this one is pz. Is that clear?
Yes.
Now I am going to fill the electrons in these p orbitals according to the atomic number. If the atomic number is 5, then 1 electron will go into the px. When the atomic number is 6, which means the p subshell will have 2 electrons. Now the second electron of the p subshell will go towards the py. It will be filled in the py, it will not be filled in the px. It will be considered wrong. Are you getting the point?
Yes.
And after carbon is the nitrogen with 7 atomic number, which means it will have 1 more electron than carbon. Now that extra electron will now be filled in the pz. It will be filled in pz. I could also show this electronic configuration in this way, that px had 2 electrons with opposite signs and py had 1 electron. That configuration would consider be wrong, because according to the rules you have to place electrons singly in different orbitals. As you can see that 1 electron was placed initially in px, then second electron was placed in the py, and the third electron was placed in the pz. They are not being filled in the previous orbitals. Are you getting the point?
Yes.
So after these 3 orbitals are singly filled, then if you have a higher atomic number, which means a higher electron, then the next electron will now be filled back in the px orbital. It will be filled in the px orbital again. So this is a proper order. The electrons are filled from px to py, then pz, and when there is another electron, it will again start filling up from px to py and pz, but this time in the paired form. So electrons are being filled but in the paired form. Is that clear?
Yeah.
So that's the order of filling the electrons. You cannot, if for example, if I want to show the electronic configuration, then it will be considered wrong if you uh, if you put one electron in the px and two electrons in the py and two electrons in the pz. It will be considered wrong. It will also be wrong if you put one electron in py and two electrons in pz. It will also be wrong way. Is that clear?
Yeah.
Okay, so I have shown you the filling of the electrons from atomic number 1 to 10. Now you just need to apply this on the elements of period or the next period. Next period will follow the same rule. So now let's see what's shown in your book of OCR. Filling the orbitals. So they are starting from boron up to oxygen. The boron's atomic number is 5. They are not showing okay, the atomic number is 5, which means there must be 5 electrons. Now the electrons of the first shell are shown filled up here. Then you will be left with 3 electrons. Out of these 3 electrons, 2 electrons are filled in the second shell because it's 2s, because its energy is higher than 1s. When it is filled up, then you will move to the next subshell. The next subshell is p subshell, but you will now have just 1 electron left, so that 1 electron will now be filled in the 2p subshell. So 1 electron is shown, but in the px. It is shown in the px, not in the py, not in the pz, just in the px. Is that clear?
Yeah.
So after boron comes carbon, which whose atomic number is 6. It will have now 1 additional electron. Now that additional electron will be filled in the py, not in the pz, not in the px. It will only be filled in the pz because electrons will fill singly first. They will be filled singly. When all the orbitals are occupied singly, they will then start pairing up, but starting from the x. They will start pairing up from the start of the orbitals. So that's the rule which you have to follow while filling the electrons. Will you remember this rule?
Yes.
Okay. And they have shown the same electronic configuration but in different style. Here the electrons the electronic configuration in without boxes by simply using the shell numbers, the subshells symbol, and the superscripts are showing. These superscripts represent the number of electrons. So 1s2, 2s2, 2p1 means there are 2 electrons in the s, 1s, 2 electrons in the 2s, and 1 electron in the 2p. And if you represent this electronic configuration in terms of the orbitals, then the second column will be followed. Orbitals occupied. This is the column in which the orbitals are shown with the electronic configuration. I hope it's clear to you. Is it clear to you?
Yes. It's clear.
All right. Now the electronic configuration of the ions. It is a very easy topic. I can show you the same topic from my notes. For example, if we are given any particular ion made up of any element, we just need to know that what charge is present on that ion and what does that charge mean. Suppose if the charge on the atom is positive, then what does it mean?
It loses electrons.
Exactly, it has lost the electron, but we should know how much electrons are lost. So for that purpose, you will see at the charge present on that atom. For example, the sodium ion is shown. The sodium ion means it has lost how many electrons? How many electrons are lost by sodium here?
1.
1. So initially its electronic configuration was 1s2, 2s2, 2p6 and 3s1. When it was just an atom, sodium atom, then its electronic configuration was like this. But after the formation of the sodium ion, it means it has lost one electron. So that one electron will be lost from the last shell and its subshell. The last shell and its last subshell. Here the last shell is third and it has just one subshell. So the electron lost will be from the 3s. So when writing the electronic configuration of the sodium ion, you will not write the 3s. It will be omitted. Is that clear?
Yes.
Okay. Now take an example of the anion, which means the negative ion. So if I write the electronic configuration of fluorine atom, then it will be, what shall be its electronic configuration?
One S2, 2S2, and 2P5.
Yes, very good. 2p5. Its configuration 2p5, but after the formation of the anion, it means it has gained one electron. Now that additional one electron will come in the 2p subshell. So the electron has come in its 2p subshell. That's why it will now become 2p6. And if I expand this to p5, what should be the electronic configuration if I want to show this configuration in terms of orbitals?
What do you mean?
Like if I want to show this configuration of 2p5 in terms of orbitals, then how should I write it?
The boxes.
It can be boxes or it can without be boxes.
And you put
Like 2px, 2py and 2pz. How would I place these 5 electrons in these 3 orbitals?
2P2.
No. In terms of orbitals.
Not sure.
2 electrons in px,
Yes.
2 electrons in px, and how many electrons in py?
2.
2. And how many in pz?
1.
1. Good. And if I write the configuration for F negative ion, then how would I write the same orbitals?
2 in the 2px, 2 in 2py, and 2 in 2pz.
Very good. So that's how we would represent them. So now you know how to fill the electrons when we have the atoms and when there are the ions of the same atoms. Is that clear?
Yes.
Alright, so we have covered this topic of the orbitals, shells, subshells, energy levels. I hope it's clear to you now.
Yes, it is clear.
Alright. Which topic do you want to start in the next class? Present in the last group of the periodic table, so it means that all of their shells are completed. Their shells are completed with the electrons. Their orbitals are never incomplete. So for helium, its first shell is completed, for neon, its second shell is completed, like all the orbitals and subshells are complete. And for argon, all the subshells and the orbitals of up to quantum number 3 are completed. Is that clear?
Yes.
Okay, so that's all about the electronic configuration. Okay, Hisham, do try to attempt some questions of this relevant chapter. Okay,
Yes, I will.
and you will tell me that which question did you attempt in the next class.
Okay. Yes.
Okay, Hisham, take care and Allah Hafiz.
Allah